Alright, next step is let's take a look at what the standard form of a quadratic function is. Now, remember we said in general we could look at something like this and know that it was quadratic. Oops, we'll get the A back out there. So we could set something up like this. Now, standard form is going to be a little bit more helpful because it's going to tell us a few different things about the equations that we're dealing with, and hopefully to shorten it up when we do some graphing. So it's going to take a look like this. So that's how standard form looks. Now there's a lot of information that we can pull from this. One of them, our vertex right away. Our vertex are the values that come from h and k. Now a couple things from the vertex. The h value, if we write it as an equation, x equals h, that's what's known as our axis of symmetry. So that's the mirror when we draw our parabola. The other part that we can pull off of this right away is our k value. And that k value is either going to be the maximum or the minimum, depending on if our parabola opens down, it's going to have a definite maximum. If our parabola opens up, it has a definite minimum. So the vertex tells us quite a bit right there as well. Now the other part of this that we need to know, the a value, we talked a little bit about this in one of the earlier videos. When a is positive, it opens up. When a is negative, it opens down. And the other thing that a controls is as a gets bigger, so as a is greater than 1, or the absolute value of 1, because it's positive, if that's the case, then we're going to end up, oops, I should redo that, sorry. If the absolute value of a is greater than 1, then this thing is going to get much steeper. If the absolute value of a is between 1 and 0, so basically a fraction, this thing is going to get wider. And again, obviously, positives and negatives is going to flip it upside down one way or the other. So that's our setup and what we're looking for when we set this equation up. All right, now let's take a look at some of the work that's involved in this. So here's the equation that we're going to start with, and they're going to ask us to actually sketch this graph eventually, but for the time being, let's just simplify. And we're going to have to go back and do some completing the square. So you have to maybe do some review with this. So f of x equals 2x squared plus 8x plus 7. And again, there's many ways to do the completing the square. I'm going to go with the way that I'm comfortable with and the way that you've seen in class. So we're going to start by moving the constant over to the left side with our function notation here by doing subtraction. And I'll do every step here. You will be able to combine some steps and shorten this up. Alright, now on the right side, we always want to take this lead coefficient and factor it out. If it's not there, if this would have just been x squared, it'd actually just save us a step. So what's going to happen here is we divide that 2 out, and we're left with this. Now we're also going to do our plus something squared step. And again, this is where I do it a little different than some people, but eventually end up in the same spot. So here, because the 2 is hooked with the something squared by distributive, I also have to do plus 2 times something squared on the left side. Don't forget that coefficient. Now remember, all we do to find this value here, we divide this middle term by 2. So positive 4 divided by 2 is positive 2. We fill in both sides. Alright, left side's pretty easy. We just simplify. 2 squared is 4. 4 times 2 is 8. 8 plus negative 7 is positive 1. So you get f of x plus 1. On this side, I do my shortcut, where I take the two squares and turn them into a single square. So x got squared, positive 2 got squared, the two squares become 1. So again, remember, x plus 2 all squared is actually going to be equal to what's in here. So different format. Now I can subtract the 1 back over to the right side. And this is what I end up with. And once we get it there, there's our standard form. So now again, this gives us a lot of information. The 2, it's positive, tells me that this thing is going to open up and be a little skinnier than the parent function because it's bigger than 1. There's my h, and there's my k, so that tells me my vertex is at -2, -1. And remember, our x plus 2 equals 0, so if I set that equals 0 and solved it, that's why this is a -2. So on here I could say x equals -2, that's my axis of symmetry. And because I know it opens up, because of my positive a value, it's got a bottom, so it's going to have a minimum at -1 coming from my y value.